Alright, this is my factor by grouping video. So factoring by grouping is taking an expression that's separated by a plus or a minus sign or something like that and taking out every single common element, putting those all out front, and then having one parentheses at the end where everything that makes those two expressions on either side of the plus or minus sign, this one or this one, whatever makes those different is going to go in that last parentheses. So you're going to pull out everything that's the same, and in the last parenthesis you're going to put only what makes them different with a plus sign in between. So we're going to go through and do that now. So first we look at the first terms, 2x squared and 10x cubed, and we say, hey, what's the smallest thing that is common to both, the largest thing that is common to both of them? And in this case, a 2 is the largest number, and then x squared, because x cubed is bigger than x squared. Okay, now we go on to our next term, x minus 1 cubed and x minus 1 to the fourth. X minus 1 cubed is smaller, so that one is common to both of them. X plus 3 to the fifth and x plus 3 to the fourth. X plus 3 to the fourth is smaller, so that's what goes next. Yeah. And lastly, 2x squared plus 3 to the fifth. That is actually common to both of them, exactly the same, so we can pull out the whole thing. So this is all of the stuff I am pulling out here. Now what goes in my last parentheses is what is common to both. Or sorry, what makes them different. So in my first term, if I factor out 2x squared, that first term goes away. X minus 1 cubed, that entire thing goes away. X plus 3 to the fourth, we're still going to have an x plus 3 left over. So I'm going to write an x plus 3. And then 2x squared plus 3 to the fifth, that goes away. So all I have left after I factor out all the biggest terms I can from both of these is an x plus 3. Now in my second term, because I have 10x cubed, I'm going to have a 5x left over, because 10x cubed divided by 2x squared is 5x. And then I'm also going to have, let's see, x minus 1 cubed. Oh yeah, I'm going to have an x minus 1 left over. So 5x times x minus 1. And then x plus 3 to the fourth, gone. 2x squared plus 3 to the fifth, gone. And that's it. So I'm kind of close to done, but this back parenthesis here, this can be simplified. So I'm going to go through and do that. So I'm going to rewrite all this junk. 2x squared times x minus 1 cubed times x plus 3 to the fourth times 2x squared plus 3 to the fifth times, let's just simplify this last parenthesis. X plus 3 plus 5x squared minus 5x. And one last step. 2x squared times x, all this garbage. And now I can simplify this final one. 5x squared minus 4x plus 3. So this is factoring by grouping. I finished with this problem here. And you might ask, why is this useful? Well, if we look at this initial expression, if I asked you to tell me where this thing goes through 0, I don't think you'd be able to tell me. Looking at that, you'd be like, maybe something. But if we have just one expression, we can evaluate this, and this. And since it's all just one big expression, each of the spots where those are equal to 0 will be a spot where our entire thing is equal to 0. So at 0, at 1, at -3, at nothing, this is never 0, and at wherever this is 0. which we can use the quadratic formula to figure out. So negative b plus or minus the square root of b squared minus 4ac. Oh, that's a problem. I don't even need the over 2a because I can look at this and say, hey, 16 minus 60, yeah, that's negative. So square root of negative, no good, no real root there. And we're done. Those are the only spots where this is 0. So that's where this comes in handy, is useful. I'm going to do another example. This one's, I think, a little simpler. So our second example is this 44b guy over here. So between 6 and 8, what is common to both of those is a 2. And then x minus 2 to the 5th, x minus 2 to the 6th, I have x minus 2 to the 5th as the term that is common to both of them. X plus 1 to the 8th, x plus 1 to the 7th, x plus 1 to the 7th. Alright, I got all my common stuff. Now it's time to get the leftovers in the final parenthesis. I'm going to get a 3 in the first term, because 6 divided by 2 is 3. And I'm going to get an x plus 1, because the x minus 2 to the 5th cancel out. And I get 1 x plus 1 left over. Alright, 8 divided by 2 is 4. And I'm going to get an x minus 2 this time, because x minus 2 to the 6th divided by x minus 2 to the 5th is x minus 2. And the x plus 1 to the 7th cancel out. So now I'm going to do the same thing, although I have way less junk to write this time, which feels pretty good. And I get 3x plus 3 plus 4x minus 8 in this final parenthesis. Now I'm going to simplify that last parenthesis. 2 times x minus 2 to the 5th times x plus 1 to the 7th times 7x minus 5. Now, just for like proof of concept sort of thing, I'm going to show again how you find the zeros. If that was a question I was asking, the zeros would happen at 2, at negative 1, because that's what makes this 0, and at 5/7, because that's what would make this last parenthesis 0. So this is a really nice way of taking pretty complicated expressions and finding where they're equal to 0, which turns out is pretty useful in calculus.